Hey everybody, let's talk about multiplying large numbers mentally. Let's talk about doing some math in our head. I don't usually ask you to do your math in your head, but as we get a little better, what we need to do is develop some skills that we can do quickly. Like you probably remember your elementary school teacher telling you needed to know your multiplication tables. You need to be able to memorize them so that you could recall them quickly so you could do more complex problems. I'm telling you the same thing. Now, in order to do more complex problems like division with two-digit numbers, you need to be able to multiply larger numbers quickly in your head. And what we're going to do is learn a trick to help us do that. We call it the distributive property, right? And it really helps us to think back for a quick sec to the time when we used number cubes. So take a look at these cubes and this rod that you see on the screen and think about how much is being shown there, or what's the value of these rods and cubes altogether. If you said 16, you're correct, right? This rod is a group of 10, and then these cubes are worth 1 each, so that's 10 plus 6. That represents 16. Now this is going to help us use the distributive property, or understand the distributive property, right? So I've got one group of 10 and 6 groups of 1, that makes 16. But what if I wanted to multiply 16 times 3, right? Some of us are going to reach for our pencil, and we're going to do something like this. We would write 16 plus 16 plus 16, and add these up. 6 and 6 is 12, plus 6 is 7, 6, 7, 8. That's 18, I'll carry the 1. That's 130 plus 10 is 48. Others of us will just multiply. We would do 16 times 3, and we'd say 6 times 3 I know is 18, and I'll write the 8 here, and I'll carry the 1, just like I did over here. And then I'll say 3 times 10 is 30, plus 10 more is 48. And there we are. But I'm going to ask you to be a little quicker than that. I'm going to ask you to do it mentally. All right, so how do we do that? Well, let's go back to those rods and cubes. So 3 times 16. Look at these. Does this represent 3 times 16? And the answer is it should, right? I have a 16 here, there's a 16, and there's a 16, and there's a 16. Right? Now, if I just try and solve it like this, I'm back to counting. I've got 16 plus 10 plus 6 plus 10 plus 6, but luckily with cubes and rods, I can rearrange them. So if I've got 3 times 16, I'm going to try and move them around so they're easier to add up. What if I do this? Is this still 3 times 16? And the answer is yes, of course it is. Take a look. You didn't see any new cubes show up, and you see the same number, so it must still be 3 groups of 16. But let's identify them. Here's one group of 16. Here there's a 10 and 6. Here's another 10 and 6. And here's our last group of 10 and 6. So there's our 3 groups of 16. Okay? But now it's a lot easier to multiply, right? What I can do is say that's 3 times 10, or 3 groups of 10, and over here I have 3 groups of 6. Now I didn't know 3 times 16, but I do know these facts, right? I didn't know 316, but I do know 3 times 10 and 3 times 6. And if I don't know them, they're on that multiplication table. And that's what I meant earlier in the year when I said you'll never need to multiply by anything larger than 10 times 10. Right? All those facts are right there on the times table for you. All right? So 3 times 10 is 30. 3 times 6 is 18. And if I add all that stuff together, I'm going to get the answer. That's 48. Right? These cubes, these 3 times 16s, are the same as this 3 times 16. They're both 48. Okay? Remember, this 3 times 16 is the same as 30, or 3 times 10, plus 3 times 6. Right? They're both the same amount. Just one of them is easy to do in your head and the other is not. Same. We call this the distributive property of multiplication over addition. Call it the distributive property for short. And earlier I called it a trick, and I feel terrible. It's not really a trick, it's a tool. And that tool we can use to multiply large numbers. Okay? It always looks like this. You take a multiplication problem, and you take one of the values, or one of the factors, and you split it into 2 Easy numbers, right? Let's take a look at 4 times 26. 26, obviously, that's the number that's not on the multiplication table. That's the one we got to wrestle with. So let's split it apart. And usually you want to split it apart into the number in the tens place and the number in the ones place, like 20 plus 6. That makes 26. It's easier to think about when you split it up, and it's easy to multiply, right? So let's do it. Let's distribute the 4 over the addition problem. 4 times 20 and 4 times 6. Now, some of you might be thinking, wait, hold on a second. 4 times 20, that's definitely not on the multiplication table. But remember, 4 times 20 is the same as 4 times 2 with an extra place value at the end, right? So, if we were writing it down, we would write it like this, right? Now, I want you to learn how to do this in your head, but if you're writing it down, you could write it like this. 4 times 20 plus 4 times 6. Now, 4 times 20, that's 4 groups of 20 and 4 groups of 6. Okay, now remember, what I'm going to do is take the tens and put them together. It's the same as this. And I'm going to take the cubes and put them together. So that's my 4 times 6. Okay? If it helps to, eventually you're going to be able to do this in your head, but if it helps at first, draw it out. Draw out the cubes and draw out the rods. Or just watch the video. It might be much faster. Okay, now just a quick sec. Remember, these are parentheses, right? And in the past, I've referred to them as eggs, right? Because you've got to solve the number that's inside the eggs before you do anything else. Okay, so just real quick, remember, if some people might try and multiply or add the 20 plus 4 to begin with, outside the order of operations, don't want to do that. What you want to do is make sure that you solve the problems inside the egg first, right? So we're going to do the 4 times 20 first and the 4 times 6 first. You've got to let whatever's in that egg turn into whatever animal it's going to turn into. For example, I've told you that this could be a dinosaur egg, or it could be a snake egg, or it could be a chicken egg. You don't know. If you crack it open and all you see is yolky goo, you'll never know what it is. So don't crack that egg open until you have found out what the value of that is. Right? In this case, that egg is going to turn into 80. And this egg is going to turn into 24. Right? But we've got to let them finish cooking before you break them open. Because if you break open an egg before you find out what it's going to be, you make a mess. If you crack that egg open, you're going to make a mess. And there you go. Okay? So use that distributive property. Oh, by the way, let's solve this problem, right? 4 times 26 turns out to be, 4 times 20 is 80, and 4 times 6 is 24. So the answer to this problem is, 80 plus 24 is 104. Or I should say 104. Okay? So using the distributive property, we can solve those. And lots of other numbers. All right. That's it for today.